advocate at IBM Dubai, and with me today I have Fawaz. Fawaz, would you like to introduce yourself?
Hello, hey everyone. Good evening, good afternoon, good morning, depending on what part of the world you're joining us from today. My name is Fawaz Siddiqui, and I am a developer advocate at IBM, and I'm really happy to be here to be presenting you such an amazing use case. Anam, over to you.
Thank you. So on the screen, you see there are some links that you can join for the meetup page or developer.ibm.com, and for our community, it's on Facebook, and we'll be putting these links in the chat below. So for our session today, we'll be discussing about how you can build predictive machine learning models quickly and easily. Before we get started into the presentation, here are some links. You can click on the green button down below, workshop resources, to get access to all these links. And you can please log into IBM Cloud or sign up to IBM Cloud using this link so that our efforts can be tracked back. And you can take the survey and let us know how we are doing, what you would like to see in the future, and what could be improved. Now, what is Call for Code? So Call for Code is a global challenge that invites developers and problem solvers from all around the world to build and contribute to open source software solutions. And you can, so it's almost reaching towards the deadline. So I hope for all of you who are participating, you have all the code and everything submitted and everything ready to submit. And for the awards, you get a $200,000 global challenge winner for the US, and then 10,000 USD for university challenge winner, and 5,000 USD for Middle East and Africa region. Now, the call for code, the theme for this year's call for code is climate change, where we had 3 starter kits: clean water and sanitization, zero hunger, responsible production and consumption. There were starter kits available, and if you're still interested, you can look at them on the link over here. And yeah, so now for the housekeeping for this for Crowdcast. On the top left, you will find the title of the webinar. And on the right top, you will find IBM Developer, where you can follow us and you will get notified about all our upcoming events. Moving to the top right, bottom right, you can chat with everyone over here, and just towards towards the left of the chat, you will find the Q&A session as well as a poll question. So you can answer that and let us know what stage you are and how much you've heard, so we can change our presentation accordingly. And for the workshop resources, you can click on the green button that says workshop resources, and you will get the GitHub repository and all the links available. Now, for our agenda today, we'll be talking about the use case that we're going to be using today. What is the AI, ML, deep learning, and data science? We'll then dive into machine learning and the machine learning pipeline. We will move on to guided ML and modular flows, talk about evaluation, and then Fawaz will take you over the hands-on session. Now, for our use case today, it's fraud detection, fraud prediction using SPSS Modeler flows. We will be using a fraud data set to predict credit defaulters, and you will use different nodes to get outputs and analyze the main features. And you will see how easily you can build models to help aid in faster decision making. Now, before that, let's dive into some of the terminologies that we use every day. Now, to begin with, what is artificial intelligence? AI refers to the ability of a computer system to act like a human being by performing tasks that you would normally associate with humans. So tasks like learning, self-correction, communicating, etc. And the common misconception about AI is that it's supposed to replace humans. However, it's not exactly accurate, because the way we see it is that AI is supposed to augment or enhance our abilities as humans, so to allow us to solve even more complex problems. Now, AI is the technique which enables machines to mimic human behavior. Basically, it's a broader concept of machines being able to carry out tasks that we could call smart, like a program with the ability to learn and reason like humans and solve tasks, But with this, we don't have any idea of how we will solve these issues. And this is where machine learning comes in. So machine learning is like the current application of AI where the system improves their performance in a given task using statistical methods and data given. And deep learning is a subset of ML, and this uses neural networks to analyze different factors, classify images, and so on. And neural networks are inspired by the structure of human brain, and that's the whole concept of deep learning and how it works. So deep learning is basically the next evolution of machine learning. Now, when we are moving on to data science, it is the process of and method for extracting knowledge and insights from large volumes of disparate data. It's an interdisciplinary field involving mathematics, statistical analysis, data visualization, machine learning, and a lot more. So, data science can use many of the AI techniques to derive insights from data. For example, it could use machine learning algorithms and even deep learning models to extract meaning and draw in inferences from data. So there is some interaction between AI and data science, but they are not a subset of each other. So both AI and data science can involve the use of big data. Now, some of the tools of data science that you can use for coding, you can use Python, you can use Jupyter Notebooks, you can use Scala, R, and for databases, you have SQL options as well as NoSQL options such as SQL, MongoDB, Apache Spark, Hadoop. And for ethics, where you need to make sure that your model is not being biased and it's ethical, then you can use AI Fairness 360 and OpenScale or Lime. Then for visualization to give you much more understanding of your data, you can use Pandas, Seaborn, Matplotlib. And for machine learning, there are multiple libraries that you can use, such as Spark MLib and Keras, TensorFlow, Scikit-learn, and BigML, and a lot more. So now, what is machine learning? The formal definition of machine learning is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. So, in simpler words, machine learning is a subset of AI that uses computer algorithms to analyze data and make intelligent decisions based on what it is learned without being explicitly programmed. So, machine learning algorithms are trained with large sets of data and they learn from examples. They do not follow rule based algorithms. Machine learning is what enables machines to solve problems on their own and make accurate predictions using the provided data. And that's what we'll be showing you today with the fraud prediction. So there are two types of machine learning approaches or paths. We have supervised machine learning and unsupervised machine learning. Now with supervised machine learning, it is the data that we provide to our algorithm is already labeled. So the machine knows that for a specific type of data, it will get a specific result. And it basically has a whole set of examples for this case. It's also called labeled data because we feed the machine with the data and its output. As for unsupervised learning, there is no label. So the machine doesn't really know what the output will be for a specific input. The goal with unsupervised learning is to learn about the structure of data, look for patterns, trends, or even segmentation in the data. So you might have heard names of the algorithms, but if we were to categorize them, then classification and regression algorithms fall under supervised learning because in classification, we are classifying our data into certain groups or classes, and that means we are labeling the data. A classification technique is used for predicting the class or category of a case. For example, if a customer will churn or not, if a disaster will happen or not, red or blue, heads or tails. So the value of the output is going to be absolute, and then the problem will be classification problem. The same goes for regression, as it is a method to check the relationship between variables, like what will the value of the second variable be based on the first one. It's possible only because we are providing labeled data in form of the example. The regression or the estimation technique is used for predicting a continuous value. For example, things like the price or of a house and based on its characteristics, or to estimate the CO2 emission from car engines. Let's take an example. If we have a data set with details of different kinds of real estate properties, for example, location, area, number of rooms, etc., and if we were to use the data to determine what kind of property it is it a villa, is it an apartment, or a studio apartment, since the output here is absolute, it would come under classification. However, if we were to use the data to determine the prices of these properties, that would come under regression. And this is because price is a continuous variable, and the price can range from $100 to 101 to 101.1 and so on. So the value can range from different values. Hence, it comes under regression. Now, moving on to unsupervised learning. There are no labels, and the most common and famous algorithm is clustering. So the machine tries to group data based on their common features. Clustering groups of similar cases, for example, can find similar patients or can be used for customer segmentation in the banking field. With the association technique is used for finding items or events that often co-occur, for example, grocery items that a customer could buy together. Anomaly detection is used to discover abnormal and unusual cases. For example, it is used for credit card fraud detection, and dimension reduction is used to reduce the size of data. So, machine learning algorithms inspired by the human learning process iteratively learn from data and allow computers to find hidden insights. These models help us in a variety of tasks such as object recognition, summarization, recommendation, and so on. And machine learning impacts society in a very influential way. So here are some real life examples. To start with, how do you think Netflix and Amazon recommends movies or videos or even TV shows to the users? So they use machine learning to produce suggestions that you might enjoy. Now, this is very similar to how your friends might recommend a television show based on their knowledge of the type of shows you like to watch. And banks can make decisions when approving a loan application because they use machine learning to predict the probability of default for each applicant and then approve or refuse the loan application based on the probability. Now, telecommunication companies use their customers' demographic data to segment them or predict if they will unsubscribe from their company the next month. And there are many other applications of machine learning that we see every day in our daily lives, such as chatbots, logging into your phones, or even computer games using face recognition. So, moving on to the machine learning workflow, there are multiple steps. So let's have a look at them one by one. Data collection and preparation. The process is the process of gathering data. Depends on the type of project we desire to make. So if we want to make a machine learning project that uses real-time data, then we're going to build an IoT system that uses different sensors. And the data will then be collected from various sources such as files, databases, sensors, and many other such sources. But the data that we collect cannot be directly used to perform analysis process, as there might be a lot of missing data, extreme values, unorganized text data, or noisy data. So to solve this problem, data preparation is done. And now data preprocessing is the process of cleaning the raw data is collected in the real world and is then converted to a clean data set. In other words, whenever the data is gathered from different sources, it is collected in a raw format, and this data isn't feasible for the analysis. Therefore, certain steps are executed to convert the data into small, clean data set. This part of the process is called data preprocessing. Now, feature selection. Feature selection is the process where you automatically or manually select those features which contribute most to your prediction variable or output in which you are interested in. Having irrelevant features in your data can decrease the accuracy of the model and make your model learn based on irrelevant features. Now, algorithm choice, as we looked before, you can look at the project that you're working with and accordingly check the data set you have, if it's going to be supervised or unsupervised, whether you would like to use classification or regression, clustering or association or dimension reduction. So you can choose the algorithm based on your project. Parameter selection. A model parameter is a configuration variable that is internal to the model and whose value can be estimated from data. Now, they are required by the model when making predictions, and the value define the skills of the model on your problem. They are estimated or learned from data and are often not set manually by the practitioner, and they're often saved as part of the learning model. So parameters are key to machine learning algorithms. They are part of the model that is learned from historical data. Now, training and validation. Once you have the data set, you are ready to train your model. This involves feeding your training set to your algorithm so that it can learn appropriate parameters and features used in classification. Now, once the training is complete, you can then refine the model using your validation dataset, and this may involve modifying or discarding variables and includes a process of tweaking model-specific settings such as the hyperparameters until an accepted accuracy level is reached. Now, machine learning can help a lot and can help in a faster decision making, but there are a few challenges that we face these days. And some of the challenges that we face are high demand of data scientists and machine learning engineers, but a lack of skills in the same area. So there is an imbalance right there. And traditional machine learning techniques are time consuming and require a lot of efforts. Now, 80% of the data scientists spend their time on tedious tasks that could be automated, and 63% companies see the availability of technical skills as an implementation. And how could this be improved, and how can your company benefit from it? So there's something that we call guided ML. Now, guided machine learning is a human-guided machine learning. So it's a type of supervised learning which uses a set of human-labeled training data to develop a model. In supervised learning, the algorithm learns a set of inputs along with corresponding outputs, right? Now, this comes with modular flows, and this takes us to our topic today, which is going to be SPSS Modular Flows. And SPSS Modular Flows is IBM's implementation of guided ML, and modular flows provide an interactive environment where you can quickly build machine learning pipelines that flow data from ingestion to transformation and model building without needing any code. Now, modular includes automation of several data science tasks such as data understanding, data preparation, feature selection, and modeling. How does modular flows work? Now, there are 6 different types of node categories, and most of them we'll be using today. We'll be using a variety of them. So the main 6 types of node categories are, the first one is record operations. So you can use them to perform operations such as selecting, appending, sorting, or under a record, and field operations. So these nodes are helpful in the data preparation phase. You can filter data, rename features, and choose the type of your attributes. The third node we have is graphs. Now, this node is so nodes in this section will help you with the basic data exploration and understanding the distribution or relationship between features. And the fourth node is modeling. These nodes provide different modeling algorithms for different types of problems. Outputs node, they are helpful in understanding your data and model, and you can display results in table format or get a report on evaluation parameters of your model. Now, the last node that we have is the export node. So after processing the model, this node will help you export data from the flow editor to your project. And so basically what you do is you drag and drop the node onto the canvas and right click to take further actions such as open, preview, or run. Once you have built a model, you can score it using the table node to take a look at your predictions. This will all come together when Fawaz will perform the hands-on session. But before that, let's look at the last part of the machine learning part is evaluation of your model. Now, evaluation of the model is an integral part of the model development process because it helps to find the best model that represents our data and how well the chosen model will work in the future. So for training a model, we initially split the model into three sections, which are the training data, validation data, and testing data. So you train the classifier using training data set, and then you tune the parameters using the validation set. And then the test performs performance of your of your model on unseen test data set. So an important point to note is that during training, the model, only the training or the validation test is available. The test dataset must not be used during training the model, and the test set is only available during the testing phase of the model. So that's it for the presentation. Fawaz will take over and show you how to perform the fraud detection.
Hello, hey everyone. Thank you so much, Anam, for such an interesting presentation and really enlightening people with about what we're going to talk about today. I'm going to start sharing my screen. Give me a second, please. All right. So before we start, there are some things which you all need to do. The first thing is you need to sign in into IBM Cloud. Please use the link which I'm sending in the chat, as that will really allow us to track our efforts. So I've posted that link in the chat now. It's a login or sign up for IBM Cloud. The next thing is you need to open the hands-on guide. So in case you get lost somewhere, you can refer back to the hands-on guide, and it will tell you at what step we are. So it's a step-by-step guide basically. And lastly, you need to download the hands-on guide, by the way. So how can you download that? You can just once you click on the hands-on guide section, you're going to see this page and just click on download. Just click on download zip basically, and you'll be able to download that. So that's on the second link. And the reason why we're downloading this is because we need the data set, which is there in the data folder. So once you download it, it's going to download as a zip. Just unzip it, and you should see the data. Okay. So the data is basically a German credit risk data. And what's going to happen here is that we're going to look into the data as of now. And we're going to see the checking status. We're going to see the loan duration a person has taken, the credit history, the purpose of the loan, the amount of loan, existing savings, and the residence duration. There are a lot of things which really take into play when it comes to fraud prediction, when it comes to recognizing the risk, right? So we get all of these, and then we finally see, and we have the last column which we are going to predict today, which is the risk actually. So as you can see in the last column, and there's no risk, there's no risk, and then there are values with risk, and this is something which we are going to predict in our modular flow. So to get started, I believe if you all have signed up, we can continue. If you have signed up, please do give a shout out in the chat so so we can see, so that I can continue basically with the next step. So if you signed up, just write a yes in the comments. So from there we can continue. Perfect. So I see people have logged in already. That's amazing. Okay. Now, the next step would be initializing a Watson Studio service. So I'm going to search for Watson Studio. Okay. And you're going to see Watson Studio, right? You're going to click on that. And I will talk to you about these services, what is every service as well. So we're going to search for Watson Studio, select the region as Dallas, US South. And you can click on the light plan and click on create. So it's going to create the Watson Studio instance. So select the region as US South, Dallas, and click on create after selecting the light plan. The other service which you need to create is the object storage. So just like how we created Watson Studio, to search for object storage and click on object storage. And you can again create a light plan. The name, you can change the name if you like. I'm going to keep it as is. And we're going to click on create again. So once you've created these two services, give a shout out in the chat that yes, you've created the service, and then we're going to proceed in the workshop. So was anyone not able to create the service? Okay, people are able to create the service. Perfect. All right. Okay, so this is your IBM Cloud panel, I would say. Okay, you see a resource summary on how you are using your resources, the status, and user access. So we're going to click on View All in the resource summary. So if in case you don't see the screen, just click on IBM Cloud on the top left corner, and you'll be able to open that. And you're going to click on Resource Summary, View All. So you see that under Services and Software, you see one of the services, which is Watson Studio, and it should be active. And then there is storage, that should be active as well. What we need to work with now is Watson Studio. So click on Watson Studio and click on Get Started. So let's wait for it to load. Okay, sorry about that. Oops. I'll just stop sharing my screen for a second, please. Okay, there we go. All right, I'm gonna continue sharing. So you should get something like this, and you can click on Go to IBM Watson Studio, and you should be good to go. It's loading for me, my internet. All right, so once everyone is on the screen, then we're gonna continue. So I'll just wait for you all to make sure everyone is on the screen. And yes, I will zoom in a little bit. All right, so if you're in the screen, give a shout out so we can continue. All right. So perfect. All right. So now at this point, we are going to create. So what have we done till now? We've created two services: Watson Studio, Object Storage. We've finally accessed Watson Studio, and we all are on the same screen right now. So what you're going to do is you're going to click on New Project, and we're going to call it. Um, you're going to click on Create an Empty Project, and you're going to call it anything you like. Basically, I'm going to call it Modular Flows. We're going to click on Create. Let's wait for the project to create. All right, my project is created. So I just want to take this opportunity by the time people are signing up to talk about Watson Studio. So basically, it's your one-stop platform for all your data science needs, right? You have your assets where you can manage your assets and upload assets, which we will be doing today. You have a lot of environments to run your Jupyter notebook and also your ETL jobs. So we have Data Stage, which is our ETL tool. We have Spark environments and Python environments through which you can run your notebooks. You can also set up jobs and to make sure that there's scheduling between your jobs, and you can also, based on those jobs, you can get real-time data from various databases which you can use. You have access control. This is basically if you want to collaborate with someone on the project, you can give them access to your project. It could be someone who is outside of your IBM Cloud account as well. And finally, the settings is just basically housekeeping and the associated services and the access tokens. You can also link your GitHub repository for a particular project here. So in case you're working on a Jupyter notebook, you can link your GitHub repository, and from there, it's going to save the changes on the Jupyter notebook and on GitHub directly. So our main thing today, it's the assets tab, right? Before we even go ahead, I want to talk about what other services are there in Watson Studio. So you can add data, you can add your data. So we're going to be doing that today. You can add a data connection. You can add connected data. You can add auto AI experiment, which is somewhat similar to guided ML, but it's very much automated. You can run notebooks. You can create dashboards. You can deploy a model from file. You have natural language classifier. You have federated machine learning experiments, which you can run, deep learning experiments, modular flow, which we'll be creating today, data refinery to clean your data, and decision optimization to actually run your Cplex engines, basically. So now what we're going to do is that the GitHub repository, which you've downloaded already. So if you go into the data tab, data folder, so you'd have something different based on your Explorer or Finder if you're using a Mac. But just go in the data folder and grab this file, which is German credit data. And what you're going to do is on this is on the right side, you see this data panel. You're going to drag and drop that CSV right here. So now it's uploading the data onto the platform. And it's uploading it to object storage, and it's successful. So now, if you've uploaded your data, let me know, and then we're going to continue from there. Done. All right, people are done. I'll just wait for 2 more minutes, and then we can continue. Okay, done. Anyone gonna wait for 1 more minute and then we can continue. All right, data is uploaded. Perfect. Okay, so now let's continue on the next part of this workshop, which is the modular flows. Everyone's been waiting for that. So you're going to click on Add to Project, and you're going to select Modular Flow. And so there are 3 ways you can actually create a modular flow. You can create a new one. You can export a SPSS modular flow file if you have one of those. It has the extension .str, or you can also create some examples if you want. So we have a drug study example, total satisfaction, sales promotion study. Everything's using a different algorithm, but yeah, you can try that on after the workshop as well. We're going to create a new one, so I'm gonna call it a churn risk or something of that sort. Just make sure that I highlight it, and I'm going to click on create. So now it's creating our new flow, and I'm going to make you go through the tool before we even dive deeper into the workshop or the main content where you're going to predict things. So let's continue. Let's wait for the runtime to start, and then let's go ahead with the rest. This might take a bit of while. Safe, yeah, the recording is available on the same link which you're accessing right now. So yeah, you can come back anytime and rewatch it. That's completely fine. So this might take a bit of time, just in case, depending on your internet speed. Mine is not favorable today, so let's just wait for that. But anyways, I'm glad it worked, right? My internet's been very slow today. Okay, so remember the palettes. Okay, before we even go through this, is everyone on the same page where I am right now? Okay, perfect. Okay, so I'm going to continue for the sake of time. And now, remember the 5 operations, or some of the operations what Anam was mentioning in the presentation. So there's import, where you can import data assets, user input, simulation generation based on, you can simulate your data, and even import extensions. In terms of record operations, you have a lot of record operations here. So you have select, you have sample, you can sort your data, balance it, you can select distinct data, aggregate it. There are a lot of aggregators which are available here, or I would say the record operations which you can use to transform your data. Then there's also streaming CTM, and there's also Cplex optimization as well. Then you come to the field operations. So this is basically to filter any data. You want to fill any data. You want to reclassify. You want to bin your data. You want to set some flags on your data. That could be possible here. The interesting part here is the modeling part. So you can select various models which are already here. So we have linear models. You can use auto classifier to give you the best model. You can select auto numeric. You can select auto cluster for all your clustering based data sets. You have C5.0, CR3, CNR trees, child tree, random trees, random forest. Basically, you can really try out a lot of things. You have support vector machines, KNNs, k-means. It's a pool of a lot of it's a pool of a lot of models, right? Then we also have text analytics, which is language identifier, text link analysis, text mining. You can also generate a lot of graphs. So you can select and plot a multi-plot, a time plot, histogram, a web graph, or evaluation. And finally, the outputs. In terms of outputs, you have tables, you have matrix, you have data audit, which we're going to use today, and can also generate reports. And finally, you can export your data as a data asset export and extension export. So the first thing, so one thing I want to say about modular flows is that it's a very modular approach where you can really change things how you want them to change. And every node here has a particular function, right? So for example, if I want the data asset to be imported, I'm going to drag and drop this one right here. And we're going to click on the three dots, and we're going to click on open. So we will get this field, and we can click on data asset. And remember the data which we imported a while back, you can just select that and you can click on select. Here you have added the data asset to the flow, and let's do a data audit to see how our data looks like, okay? So I'm gonna save, and it's going to attach data set to the data asset field, our data asset node. I'll wait for that. Okay, perfect. Now we are here. The next thing what I'm going to do is I'm going to select the outputs, okay, and I'm going to select data audit, and I'm going to drag it right here on the side. And basically you can connect. So you see this arrow, you can hold and you can connect it to your data audit node, and it's going to connect right there, okay? And from there, you can see that it's already given me 21 fields. And once I select run, it's going to execute, and we're going to see what comes as an output, right? So let's give it a sec, and it should be done. There you go. Now you see this output, which is already here. You can click on open, and it gives you a lot of insights about your data. So we see that there is categorical continuous data. We can see that the validity, how the data is unique, what is the skewness. We can see how things are actually churning up within our data. This is very essential, by the way. Why? Because it does really define how you are going to work with your model. And it's one of the criteria. I believe we had a question regarding the criteria. This is one of the criteria as well, where you actually have to see how the data is looking like in the data set. Is it categorical? Is it continuous? And how is the data spread across the data set? So the next node, which we're going to choose for today, is the type node. So in case you can just select the type node. Let me find that. Just give me a second. Field operations. Sorry. Yeah. So if you go to the field operations, gonna select the stop the record operations. You're gonna drag and drop the type node. This is a very essential node, and I'm gonna come back to tell you why. So as you see, this data audit is already linked to the data set. You can link it to the type node as well. So you just have to drag and drop, and you're good to go. Okay. Now, once you select the type node, you're going to click on open. So select the three dots, and here you see why this is important. So as you can see that all of the fields which we have right now are basically inputs towards our data. Okay. And what we need to change here is the risk. Okay, we need to change the risk to a target. So what the target does is that it actually makes sure that this. So before that, actually, I forgot one step. You select on read values. So let it read first, and then I'm going to come back to the target, actually. So once you read the data, what's going to happen is that it's going to set a lot of it's going to read the values which are in the data set and actually extract what's required. So as you can see that there's everything for you, everything will be input. You need to set the risk as a target. So basically what we're telling it that, hey, you need to predict this column from all of these inputs which we have right here. This could be the checking, okay? This could be the loan duration, the credit history, the installment, the age, and what does the flag mean? It's a yes or a no. So if you notice one thing, risk or no risk is a flag. Yes or a no is a flag. Telephone, none, yes, it's a flag. Okay, and basically that's how it's coming out to be. So once you've set this, the risk field as a target, you should be good to go. So we're going to click on save. So once we save, we're going to pick up a model today, okay? And what we're going to pick up is random forest, okay? You can try it out with different models, but for this, I'm going to pick up random forest, right? We're going to connect it again, like how we usually do, all right? And we are going to click the 3 dots, which we have right here. And this is the fun part, right? This is where your data is going to be, where you're going to get the probability and the predictions. You're going to create the predict model once you click run. So once you click run, it's going to start the flow, and you're going to get an output, basically. There you go. So you're going to get a golden nugget, and basically it's the output of the risk model. And if you open it, what do you see? You're going to see some annotations which you can make and some advanced speed up scoring, performance, and everything. Okay. You can also preview it to see what's there in the preview. Let's have a look. Excuse me. Okay. So as you can see, we see the loan amount, we see the telephones, and we finally see the risk. We see if it is the result of the risk and the basically the probability, right? We see that there are values ranging from 1, basically very definite that there's no risk, and then there's also 1 for risk as well. So the next part is let's audit this action, or let's analyze this. Let's analyze this nugget further. So you're going to go to the outputs node, and you're going to grab the analysis node, and you're going to put it right here. Okay. And you're going to drag and drop. And now you will pull this and click on run. So Sumit, regarding the choice of algorithm, it's really dependent on your data, right? You see how your data is spread. Right now, I chose random forest. You can compare the performance of every algorithm, and you can get an output. So that is one thing which is very much there in machine learning, right? You need to choose the best algorithm for the data which you have or which you're using, and that's what we're doing here. But I can show you auto classifier as well, and yeah. So you're gonna see the analysis of risk. So let's open that and see what do we get. So we get that how much of how much is correct in terms of the probability. We see that 95% of the predictions are correct. How many of them are wrong? It's 1.5%, and we get a total of 5,000. Okay. Now, and this is being done by comparing the risk itself with the risk column and stuff like that. The other thing, like people mentioned, if you can use another model, 100% you can use another model. You can grab an auto classifier and put it on top here, right? You can grab it from your type node, and you're done. Okay, you can just click on run. It will start creating. So if yes, we do have visualization tools. We have Cognos embedded. So yes, there's built-in Art Studio in Watson Studio as well. So I'm running another algorithm, auto classifier, which will give everyone an analysis of how things vary. Right. This is something not in the steps, but just for to show you or to demo how things are working. Right. Let's wait for it. Starting the run. Auto classifier does take a bit of time, by the way, because it's selecting the best algorithms for you. So let's just wait for that. But if you have any other questions, you can post it in the chat. By the time this is running, I'll be more than happy to answer them. Our model is running, and we should be good to go. So just like how you saw a golden nugget at the bottom, you're going to see it for auto classifier as well. But please make sure you run so that you can see the results. Perfect. So now you see another risk one, and you can select on view model, okay, and you can see how the model is looking like. It's loading, and it's loading. Okay, nice. Give it a second. Let me click on view model again. Thanks to slow internet. Okay, it should load perfectly for you, but basically it tells me that how the model is looking like and what models are there. Basically, the model type is listed for each model, and you can see that. Okay, that's something that's an issue with my. Let me try open. Yeah, no, never mind. Okay, so you can select view model, and you can go ahead and you can set that as well. Now I'm gonna try this one more time. Okay, it's not working. My internet connection is not being friendly with me today. Now we are going to also set up a graph. Okay, that's going to be our final step for today. And you can actually select the let me think. Hold on. You can select the evaluation graph. Actually, let's select that. We are going to evaluate the first model that we created. Okay, so you grab the golden nugget, and then you drag it to the evaluation. Okay, and you click on open. Oh, sorry, preview. Let it run. So Seth, yes, you can have an output towards this. You can see how the model looks like. So that's there as well. Like you can have a side-by-side comparison, and that's what we are trying to do here. I've created a random forest and an auto classifier as well. So that's one thing. Just to get back to the code, what I did was I ran the evaluation node, which will give us a graph basically. So let's just wait for that. Back to your second question, we can we backtrack that how many non-DL models reach the prediction? Basically, if you're using them, you can obviously check that in the previews and how the data is churning. You need to set up analysis nodes in between, and you would be able to find that. Okay, so click on open, and you're going to see a graph on how the model is looking like in terms of the gain. So let's have a look. There you go. We just generated the graph in terms of the percentile and the percentage of gain for the risk value. You can further go ahead with this one as well. You can set up a evaluation node for this. Really, it's really up to you to how you want to play with this, and that's how we actually came up with the analysis of risk and how we created an entire predictive model right now. So where's the predictive model, you ask? It's in the analysis node, because that's where we have set up an analysis. You can also set up an analysis for this one, the second one as well. And you can click on run, and you should be able to see an analysis for that as well. Let's have a look. Let's see how that works. Okay, so that's a new one, newly generated one. And you can see that there's a difference, right? So it's comparing the values and seeing that. So based on all what we've gotten right now, as you can see that this model is, the auto classifier model is giving us 4,173 correct predictions when it's compared with risk, and it's giving a higher wrong rate. Basically, it's 16% over 83%, 83%. Okay, but when you look at the random forest classifier, you get a better overview. I'll just click on analysis of risk. Just give me a second. Okay, analysis of risk, and you see that there is 98.5% of correct values or correct predictions, and wrong is just 1.5%. So obviously, you're going to go for the latter, right? You're going to go for the random forest one, because that gives you a better prediction and the correct values. So with this, we are done with our code lab today. I really hope everyone was able to follow. I will be answering questions in the chat right now, but let me take a while to actually answer. Is the risk component applicable for API threat protection rules? So if you have a Srini, I hope I'm saying your name right. Basically, if you have proper data, you can 100% build a flow, and you can automate this flow to run once you input data. Okay, so you need to grab the data from an API to a database. From there, you can dump the data into a connected data set, and you should be good to go. So what I understand is we have Modeler, which is a similar thing can be done with Python code, which may not be required anymore if you use one. Well, Sumit, yes, it makes things easier. Okay, as you saw, we literally created 2 models within the last 20 to 30 minutes, right? Yes, this can be used as well, or you can use Python as well. It's not a replacement. It really depends on your use case, right? You can just drag and drop nodes and build a model right away. So I really hope I clarify that. So let me ask a question as well if there's anything. So I've answered these all questions. All right then. All right, Anam, over to you. Really thank you everyone for joining me today. Now over to Anam to really wrap things up. So Anam.
Thank you, Fawaz. Thank you for the great explanation. And let me just share my screen. All right, so just to summarize of what we did, we created a Watson Studio instance, and then we imported data. We created a Modular Flow project, and we added a few nodes into that to basically give you an output and show you how quickly and easily you can do that. Then in the beginning, in the presentation, we talked about artificial intelligence, machine learning, deep learning, the hierarchy basically, where AI is the technique to make machine intelligent, and machine learning, where we use statistical methods and algorithms to solve problems and make predictions. And last but not the least, we talked about deep learning that uses neural networks to classify images and speech recognition. We then talked about data science and the different machine learning algorithms that we have, such as supervised, unsupervised, classification regression, dimension reduction, and association. Then we moved on to some of the problems with machine learning and how those challenges are coming up and how we can face them using IBM Watson Modular Flows, guided ML, and yeah. So, and then we looked at the workflow as well for the machine learning. Now, again, just to wrap everything up, Call for Code is ending on 31st July. If you are participating for Call for Code, I hope you have all your documents and your code ready to submit, if not submitted yet. And if you are still interested in looking at some of the code patterns or the starter kits, they're still available on the website, and you can take a look. For the people who are participating, you can, if you are a global winner, you get a reward of $200,000 and 10,000 US dollars for university challenge winners and $5,000 for the Middle East and Africa region. The theme for this year, Code for Code, was climate change, where we had three starter kits under clean water and sanitization, zero hunger, and responsible production and consumption. So the links to the starter kits are available here. We will post them in the chat so you can have a look. And I hope everybody is ready with the submissions. Some of the useful links that we'd like to share with you is that ibmdeveloper.com. So we have tons of resources there where you can visit and join our meetup page to get notified about our upcoming events. And if you're looking to learn more, you can visit cognitiveClass.ai or learn.ibm.com, where you can take courses and even earn badges. Now, thank you, everyone. Once again, I would really appreciate if you can take this survey and give us your feedback of what you think, how we did, what can be improved, and what you would like to see in the future. So, and if you have any further questions, you can reach out to Fawaz or me on our LinkedIn or through our emails. So that's it. Thank you, everyone.
Thanks everyone for joining today. Please do answer the survey, and if you have any questions, you can always reach out to us. And really enjoyed giving this webinar. So I'm going to post the links once more in the chat, and yeah, have a great day and stay safe. Thank you.